So the third type of reaction we're going to talk about is single replacement. And this occurs when you have an element displacing another element that's in a compound. So the way you're going to recognize if something is single replacement, it's going to be an element plus a compound, and then it will always make an element plus a compound. Okay? Not every reaction will occur. We're going to use something called the activity series to see if the lone element is strong enough to replace the element that's in the compound. So if you look at the bottom, you see that activity series. You do not have to memorize the activity series. I will give you the activity series, okay? The nonmetals are actually pretty easy to memorize because go look at the halogens, it's in order. Fluorine is the strongest. The way that the activity series works is if it's at the top of the list, it is the strongest and can replace anything that comes below it, okay? If it's at the bottom, so gold is at the bottom of our list, gold is the least reactive, it can't replace anything that comes above it, okay? So if you're looking at something in the middle, say, let's look at iron, okay? Iron cannot replace anything that comes above it. So iron could not replace potassium, could not replace magnesium, but it could replace things that come below it, which would be things like calcium. No, that's cobalt. Sorry, I don't have my glasses on. Cobalt, tin, lead, it could replace those. Now, there's one nonmetal listed in the metals. What is it? Aluminum's a metal. You know foil? Have you ever seen it? I'm just kidding. Hydrogen. Do you see hydrogen in there? H2. And the reason I obviously know that hydrogen is a nonmetal, but because of acids and water, there are some metals that will replace the hydrogen in the water and kick it out. Okay, and we saw a video of that. Remember when we watched the video of the alkali metals, and some of them are very explosive when they get in water, and that's what they're doing is they're kicking out the hydrogen, which is what's making the fire and the explosiveness. Okay, so you always have to check the activity series unless you have lithium. Lithium's going to replace everything. Okay, any other metal that it's with. Okay, so the way it works is like this. We'll do a couple. So there's the decreasing strength like we talked about. I probably should have pulled that up while I was talking about the activity series, but you have that in your notes. So let's look at aluminum. Will aluminum replace sodium? No, it will not. Will aluminum replace lead? Yes. All right, so let's do a couple of examples then. In this case, I want to know, will it replace the potassium? Yes, okay. Your metal will always replace the metal unless it's hydrogen. So metals replace metals, non-metals replace non-metals. Okay, so lithium will replace it. So it's going to kick potassium out. So it's going to make lithium chloride. It's going to take its place. So how do I write lithium chloride? LiCl, and then plus potassium. Okay. Potassium now does not have a charge because it's elemental. It's going to be the metal. Okay. Do I need to balance this? No. Okay. Now I want to say, in the next one, will tin replace zinc? No, it won't. And so if it doesn't work, you write NR for no reaction. If you want to spell out no reaction, you are welcome to. I'm lazy and just going to write NR. Okay. And you also do not have to draw the arrows when you're doing this. I just do it to show what we're looking at. Okay. And the one mistake that kids make is they want to say, they look at it and go, will potassium replace lithium? That's not what you want to look at. The thing that's by itself, will it replace what's in the compound? So will tin replace hydrogen? Yes, it will. Okay. So first thing I'm going to do is when I kick hydrogen out, my things, okay, sorry. Could y'all see those messages up there? Okay, my thing. Technology has not been my friend the last couple of days in this classroom. Everything seems to be going amok. So when I kick hydrogen out, hydrogen becomes a gas. If I were to do this reaction, I would know a reaction happened because I would see bubbles, which would be the hydrogen gas forming and bubbling out of solution. So how do I write hydrogen gas? H2. So now I need to add tin and chlorine together. Okay. Yesterday I told you when tin is reacting with, because it's one of those that has multiple charges, it will tend to be the lower charge unless it's with nitrogen, oxygen, or fluorine. No orange friends. So we're going to go with 10 plus 2. So how would I write that formula? SnCl2. And now I need to balance it. And how would I do that? Put a 2. Very good. 2 in front of HCl, and now it's balanced. Okay. Now the next one is got water. That is just a way of writing water so that you see when it breaks apart like that. It forms a hydroxide and an OH. That's the same thing, a hydroxide and a hydrogen. Okay. So we want to know, will nickel replace hydrogen? Yes, it kicks it out. So anytime I kick hydrogen out of my compound, I need to write hydrogen gas because it's gonna release as a gas. So now I need to put nickel and hydroxide together. How do I do that? How many OHs do I need? 2. And I need to balance that, and how do I do that? 2 in front of water. And everybody understands that HOH is just H2O, right? I don't want, yeah. Because when water breaks apart, it breaks apart as a hydrogen and a hydroxide. Okay? So that's how you would do the metals replacing the metals, or metals replacing hydrogen. Okay? So now let's look at the nonmetals. So their order of increasing and decreasing strength is fluorine at the top, iodine in the bottom. Okay? Oxygen fits in there somewhere in here. I can't remember off the top of my head if it's between here or here, but in a list I would say oxygen would replace it, I would tell you. Okay, so now let's do a couple examples of those. So this time we're looking at the nonmetals. Okay, do not put 2 nonmetals together, or do not put 2 metals together in these reactions. That's the biggest mistake, is they want to put, lithium and potassium together. It's not going to work. Okay, it's got to. The single replacements are happening in ionic compounds or with acids or water. Okay, so I want to see, will chlorine replace bromine? Yes. So it's going to kick bromine out, and when bromine is all by its little self, how do we write it? Br2, and then we're going to write the formula for sodium chloride, which is NaCl, and now I need to balance. So basically I just need to put a 2 in front of both of the Na compounds, right? Now, on the next one, we say, will iodine replace bromine? No, so we write no reaction. Will fluorine replace bromine? Yes. So we're going to kick bromine out, and then we're going to make magnesium fluoride. And it's already balanced. Self-balancings are the best. We like those the best. Makes our life easier. Yeah. Will bromine replace chlorine? No, so no reaction. Okay. So if you'll turn to the examples in your notes, I'll do about 2 or 3 examples, and I will let you pick which examples that we do. Not all of them. Then you're not practicing. I really don't need any practice with single replacement. I got it down, but you guys do. Okay. Blake, you picked the first example I do. Number 1. Okay. So I have lead, Pb, because it's by itself, and I have zinc acetate. How do I write the formula for zinc acetate? Okay, so I ask myself, will lead replace zinc? It will not. So what do we say? No reaction. All right. Okay, you can Okay, next one. How about, oh, there you go. You raised your hand. 3. Okay, so I have silver nitrate. Y'all tell me how to write that. AgNO3 plus nickel. Now, will nickel replace silver? By golly, yes it will. So I'm going to have silver out here by itself. And now I need to write nickel nitrate. How do I write nickel nitrate? NiNO3. And now I need to balance. How will I balance? 2 here and 2 here. And we're done. All right, one more. 7. Okay. So 7 is calcium, which is Ca, plus hydrochloric acid, HCl. Hey, just a piece of advice for all these naming quizzes we're doing. You should memorize some of those acid names that are the most common so that when you see them, they're second nature and you don't have to think about them. Because a lot of times people will see hydrochloric acid and they'll write HClO3, and that's not right. So just kind of memorize some of those. There's not that many. All right. Will calcium replace hydrogen? For sure. So it's going to kick hydrogen out as a gas. You'd see bubbles. And then how do I write calcium chloride? CaCl2. And now I need to balance, and it's very simple by doing what? A 2 right there. Okay? Any questions before y'all get going on your own? Seems pretty straightforward.